let's move forward with a base case analysis. So we have these three baristas. They're receiving orders from a dedicated set of tables that they're assigned, and they have an assigned Venus Arduino. And what we know is in the base case that these orders arrive at the rate of 26.4 per hour. Put that period in there. And they get served at the rate of 41.1 per hour. And all we have to do is to analyze one of these systems because they're statistically identical. So once you understand the performance behavior of these things, it's the same for each one. Now, what is it that we're likely to want to know about the performance of these baristas? So there's four lenses that we're trying to exploit in this case. The first is that utilization matters. So we're going to compute the utilization of one of these baristas, because that's essentially the utilization of every barista, and then reflect on that, see if there's any takeaways from that. Another lens that we can apply is this lens of just pooling matters. So what's currently being done here is that these orders are not being pooled, right? They're just independently being assigned to a barista. And one of the questions we're going to have is, should we maybe create a single order queue and have baristas serve the next, the head of line customer? So that's one possibility. Another possibility is that, we can automate this process, or maybe train the baristas. You wouldn't do both, right? If you automate baristas out the door. And so this variance matters idea is also in play. Also going to think about something more qualitative, does psychology matter? So these are the lenses with which we're going to approach this case. But what I'm looking to do is just to assess the performance of these baristas, because it's going to speak to the kind of experience that the customer is having. And so one of the key things I think every coffee shop customer is going to tell you is wait time, right? So we want to know the wait time. I'm also going to look at, and I want to know the utilization to see if, maybe we're overpaying, maybe we have hired too few here, what does it look like, and where's that going to lead us? So those are my two key KPIs that I'm sort of eyeballing, the utilization, and then also W sub S, which is my waiting time in system. So I'm going to be able to analyze this system, the base case, a single barista now, with the arrival stream as specified here. Now, we're told that these arrival streams are Poisson. Why is that likely a reasonable model? Well, we know that unscheduled human arrivals are Poisson arrivals. And unless you're having sort of like busloads of tourists show up, or, some sort of like tourists show up on the hour, or luxury retail folks show up on the hour, that's not likely in this case. Rather, you just have folks sort of walking up willy-nilly, so to speak, and entering the coffee shop entering the cafe looking for a coffee. So this unscheduled human arrivals sort of is a good match for the arrival process here. And then what we were told, in the narrative is that service times are normal, and the mean is 87.6 seconds, and the standard deviation is 83 seconds. So we're going to note that. Now, if you take a look at this, we've got a general service time, and we've got Poisson arrival. So I'm actually able to use the MG1 queuing model to analyze this guy. What, in fact, I'm going to be using is the GG1 queuing calculator. We can't use the MM1 because we don't have exponential service times. And in the base case, at least, we can't use the MD1 model. So of the calculators that are provided to us, the GGK model with k set equal to 1 is going to be our natural go-to. And that's going to allow us to figure, in this base case, just sort of establish where we are, what is the customer currently experiencing? Because if you're going to propose something, there has to be some value prop to it. And you're going to support those recommendations using analysis. So if the wait time is just not a big deal, looking to refine it, maybe it doesn't make a whole lot of sense. And the refinements are going to come looking at the number of baristas we've got, the automation, the training, maybe pulling the orders. Some of those changes can be motivated at relatively low cost. Like the training is not low cost, right? You got to pay $26.50 to get that in place. The automation would involve some disruption because you're pulling out these Venus machines and you're requiring new equipment. There's definite CapEx, impacts there. And on the psychology side, for you to determine, and then then there's the question about the utilization. So let's see where we are, and to just clear these, and go and have a look at our calculators. The calculators are presented down here. I did include links to all three, but the one that we really need is, for this base case, is the GGK. Now, when you pull this up, it's a little grayed out, so please just zoom in so that you can see what you need to do here. This is hosted on Hugging Face. It's a language model hosting site. So I'm cheating a little bit, but we used to host these calculators on Google Colab, sort of, and had folks actually execute the Python. It was a little bit, it wasn't it wasn't a luxury experience, let's say. So we tried to gloss it up a little bit and get this this app set up going for you. All right, so what I need to do is I need to put in my arrival rate. Let's just zoom right in so you can see that. 26.4 per hour. Now, for a Poisson process, CV sub A squared is equal to 1. What is this coefficient of variation? So it's generally, CV's squared is generally the standard deviation divided by the mean, all squared. All right, and so whether we're figuring C sub A, CV sub A squared, or CV sub P squared, it's the same idea. It's the standard deviation divided by the mean squared. Now, for the Poisson distribution, the mean and the standard deviation are identical. So when I divide them by each other, I get 1. That's why I have this. This is true for every Poisson process, and all of our scenarios that we're going to consider, are really hard to schedule in a coffee shop, right? So we're just generally going to have to commit to serving Poisson arrivals. Now, the service rate. Let me just clear this. Is 41.1 per hour. And the CV sub P squared is 0.879. I want to justify that to you. So we just said that CV is the standard deviation. CV squared is, I'll put a P in there for the processing. So it's the standard deviation of the processing time, which is 83 seconds. You can confirm that in the case doc. And then the mean is 87.6. This is going to come out at some 0.9 and change. And then when you square it, you get the 0.898, sorry, not 0.879. So let's do this, 898. Now, and then there's one server, because we're analyzing just the single barista. Each one of the baristas has an identical arrival stream and processing ability. They're all noobs, newly trained, and they do have the basic training. So they're all over the park. Their standard deviations are drastic. Okay, so those are the input numbers. We just go ahead and hit submit. And then we're critically interested in what we're actually getting here. So let's have a look at this. So one of the questions we have to address is, do we have too many or too few people? And this here is 64.23%. So, my first thought is, okay, it's a little low. If I had 2, I could get 66.67%. If they've worked all the time, 2 baristas. So can I get rid of the 3rd barista? So that's, one question I think that quickly pops up here. All right. Should I be moving to 2 baristas? And then the next item, we talked about looking at the utilization, and that's given us a question, or stay with 3. Are there any other possibilities that you can think about? Maybe part-time. There's maybe trying to grow the business a little bit to move this utilization up, keep the 3 baristas, grow it a little bit. So I leave that to your deliberation. Certainly some of the scenarios that we're going to analyze will feature this concern or address that issue. Now this here, this is W sub S. So this is the time from arrival in the coffee shop to receipt of the coffee, right? And it includes the coffee making process. And this is expressed in hours. Why hours? Well, I put in the arrival rate and the service rate in hours. So your KPIs, the time KPIs, in other words, the W sub Q value here and the W sub S value. This is the time waiting for your order to start. This is the time waiting for the order to start, plus the time making the order. Those are going to be expressed in hours. Now, when I multiply this guy by 60, I'm going to get the time in minutes, and you can see that it's around 4 minutes. That looks fine to me. May not be fine to you. You have to call it. You're advising, the management of the coffee shop. Personally, I'm going to wait 4 minutes, but that may not be everybody's cup of tea. Let's say cup of coffee. So what do we have? Performance and a question related to the utilization. So I'm going to end this clip here, and then we're going to explore some refinements. What would the performance look like if I stayed with the current hiring and I automated or I trained? And what happens if I pulled the orders? And then of course you can look at multiple options where you train and pull or automate and pull. And then we'll have a look at in the final clip, we'll go and have a look at two baristas and just see what the impacts of that. And again, consider innovations where you could automate, you train, and pull the orders. Okay.